Today we will talk about longitude by chronometer and also intercept. Now when we take one heavenly body, we take a sextant altitude, let's say sun. You can calculate the position line which you can later plot on the chart, and you can use either this method, long by chron, or intercept. So let's say you use this method, long by chron, and on the chart you plotted the position line. This is a force line and this is the position line which you plotted. This is the position line. Now if you do the same GMT and the same sextant altitude, but you use the intercept method, you will again get a position line, and that position line, if you plot on the same chart, it will come directly on top of this. Position line does not change. So that proves whichever method you use, position line remains the same. Now another thing you can try out is, let's say you use this method, long by chron, in which you use the DR, let's say 10 degrees north and 20 degrees east, and you got a position line which you plotted on the chart. Now if you work out the same sextant altitude and GMT using a slightly different DR, let's say 10 degrees 10 minutes north, 20 degrees 10 minutes east. Now in this case you will get a different observed longitude, but when you plot the position line on the chart, it will come directly on top of this. So position line will again be same. So that proves that whatever DR you take, this one or this one, the final position line which you plot will be the same. Now let's do another topic, how to calculate your ship's position by one heavenly body. Let's say you take sextant altitude of the sun and you want to find out the ship's position. Now this ship's position will be approximate. You might get an error of 20 to 30 miles because you are using only one heavenly body, let's say sun. You taken sextant altitude. So this method of position is only if you are not taken, if your GPS is not working for 1 or 2 days and you have got cloudy weather, you could not take sextant altitude of stars. So you can get an approximate position by this. So you take sextant altitude, GMT at the same time. From GMT you will get GHA of the sun and you will get declination. So you will have to use a world chart, and that's why the position which you get is approximate, because this chart has got distortion and a small error will cause a big error in the ship's position by maybe 20 or 30 miles. So from GMT you will get declination and GHA of the sun. Let's say GHA you got was 0 to 0 and declination you got was 10 degrees north. So then you can plot the geographical position of the sun on this chart, world chart. Now geographical position in this case will be GHA's west longitude. So your longitude of geographical position will be 20 degrees west, which you can plot on the chart, and declination is the latitude of the GP. Now why GP and GHA declination are all same, I made separate videos which you can watch later on. So latitude of the GP in this case would be 10 degrees north. So if this is the equator, this is the world chart, this is the equator, 0 degrees, 10 degrees would be somewhere here. You can plot, and 20 degrees, let's say this is 0 degrees longitude, 10 degrees west would be here. So plot this. So this would be the GP. Now once you plotted the GP, then from sextant altitude you will get observed altitude, finally you will get true altitude, and then you will get true zenith distance. Now putting your compass here and your true zenith distance, let us say it's coming at 20 degrees. 1 degree is 60 nautical miles. So 20 degrees would be 1200 nautical miles. So from here you open your compass to a radius of 1200 nautical miles, make a circle. And then also you have to take at this time the azimuth of the sun. Let's say you got azimuth 000. Now this is a position circle. So your ship is somewhere on this circle, position circle. And from the azimuth of the sun is also the azimuth of the geographical position. So from here with the parallel ruler you can draw the azimuth 000 and this is your ship's approximate position.